Good day to you from Anagalactic on this 27th day of June, a Saturday. Over here you'll see a somewhat simple diagram, but there are two curves here. And I chose this diagram for this particular video because it's time to actually discover what makes this so difficult. It was very difficult for me. I have introduced this series by admitting, quite frankly, that I made a grotesque error in a critical presentation which was being monitored by some fairly high-powered physicists and mathematicians. This was 2 years ago when I was really first exploring the Boschkovich force curve. And that's what I was attempting to explain. How it is that the Boschkovich force curve is so important in application to the nuclear force, as it is now called, what used to be called the strong force, which is the beginning of the complications and complexifications of this remarkably straightforward relationship between the proton and the proton. It's extremely simple, but you would never think so if you tried to study the subject. It used to be much simpler. And you might say, and fairly reasonably so, that the reason it's more complicated now is that we know more, but that's not the full story. So I'm going to leave that thread dangling. What we really know most about in the atom, this is about atomic structure, which is also ambiguous because there's also the nucleus, which has its own structure. But what we're talking about with the atom is two very simple particles as far as the structure of the atom goes. It's called the proton and the electron. I've already mentioned so far 2 or 3 strange or changing or ambiguous or not quite understood aspects to what is ultimately simple. And I intend to make this simple despite how this is taught or presented even in Wikipedia. The fact that I made this mistake, what was it? It had to do with what's above the line, that is the black line, and what's below it. Here, what you see above the black horizontal line is a red curve that's labeled electrostatic force. And I haven't showed this before, but this is taken from a scientific paper. The blue line is in fact the strong nuclear force, which here uses both terms. Well, is it the nuclear force or is it the strong force? You might say, as I would say, the strong nuclear force is a very well-formed term. Can you leave one of the words out? Not today you can't, because Wikipedia and other sources treat the nuclear force as completely different from the strong force. That there's not no relationship, but it's a relationship that depends on the most advanced calculus and the strangest ideas having to do with a subparticle, I'll just call it politely, called the quark, which has never been isolated. It's an unknown thing. It's uncertain what it is. Well, I do know what it is, although that's a little pretentious to say, but for the purposes of getting into what I want to present to you, which is ultimately simple, we have to remove these artificial barriers to understanding. So is it the strong force? Is it the nuclear force? Or is it the strong nuclear force that's being depicted by this blue curved line? Depending on what time of history over the past 100 years you're speaking of, it could be called the strong force if you go back in time. Today, the strong force has a completely different meaning than it had when the matter was simple. It's very important, first of all, to understand what is meant by the quark. the quark. And you won't see the quark listed as a particle in the standard model of particle physics, which basically has hadrons, baryons, and fermions at a high level of classification, and then muons and pions, and there's a bit else. But the classical particles they're reclassified. And when it comes to the proton, we have an extraordinarily baffling, complicating factor having to do with a mathematical discovery made by a man named Gelman, whom I believe did get a Nobel Prize for his discovery. It was back in the late 1960s that he discovered something in the mathematics of the subparticles, such as the pion and muon. These are families of subparticles. They're not actually particles, although it's hard to come up with a better word, but they're not in the same class of particle as is the electron and the proton. The reason I'm hesitating here is because there are two more potentially complicating factors having to do with what is a particle and what is not. Now, I actually know the correct hierarchy according to a geometric model that I discovered, and then my discovery was confirmed by Ruđer Bošković. And another complicating factor, to get all of this out on the table without intending to confuse you, just to show you that this is extremely confusing, but it's not going to confuse you, because I'm going to show you what every single aspect of this extraordinary conflict of models, what it actually is. The complicating factor introduced by Ruđer Bošković is that he lived 275 years ago, before any particle had ever been discovered, of course. Long before Maxwell discovered electromagnetic relationship. Long before the modern age of atomic physics. Not even the atom was known about. All right, so that's Bošković. By the way, his work has risen right back to the top, and the physicists, particularly in Europe, but not just in Europe, are fully aware that Bošković got part of the solution that the standard model particle physicists simply are unaware of. They're off on actually a wild goose chase. They're bashing protons together, mostly underneath the soil of Switzerland, but this is happening all over the world, with extraordinarily expensive, wasteful government machines. This is being run essentially by the United States government, but now other governments are doing similar experiments, all for the same reason, to see if a new source of power can be extracted from subatomic physics. You know the history of this. At the atomic level, fission energy was discovered, and it was used to murder, or unless you're a military man, in which case you don't say murder, killed several tens of thousands of people in Japan. Those were two fission bombs. But then, just about a decade later, the fusion reaction was discovered and utilized to make what was called the H-bomb or hydrogen bomb. Really, the best term is undoubtedly fusion bomb. And it goes on from there. There was more research done, and a third kind of doomsday device was discovered and actually exploded. And if you don't know about that, it's because it's been mostly forgotten. But those people, I guess, who need to know about that. At a time when the communists and the Americans were at each other's throats in the Cold War, in 1961, in October, a doomsday device was exploded over Nova Zemlya near the Arctic Circle, and it should have destroyed half of Northern Europe. And by some strange twist of fate, it did not destroy half of Northern Europe, although it would have if it had gone off the way it was intended to go off, and now we'll never know. Because another one of those bombs will never be exploded. The Russians definitely have it. The Americans, of course, have it. But probably anybody who would like to build one could build one. It would have to be a top level, a superpower, such as China, could get one of those bombs if it wanted. Nobody wants. Because whoever explodes that will destroy the Earth. Without any question whatsoever. If one of those things is exploded again, it'll destroy the Earth. Now, you know, there's probably a footnote, maybe not completely. But mankind does have the capability of destroying the Earth in one day. It wouldn't take a whole bunch of fusion bombs, which would probably take a few weeks if it got intense enough. And then all life would be exterminated. Unquestionable. Everybody knows that. But what we're talking about has nothing to do with getting a weapon. And the only reason I mention this sordid, actually supernatural, strange aspect of science, which also, by the way, explains why the governments are in outer space, is for the same reason. It's all military. It's pure military. It's not for human beings at all. It's for the military, which again, it's supernatural. Mankind should not be landing on Mars. That is not a good thing. So I throw this in because you need to know why this is so shitty. Why everything has gone to hell. Everybody knows that the world political situation is so irrational that it's almost impossible to restrain oneself from talking about Satan or fallen angels. It's just too evil and too crazy for words. Nobody has the slightest idea what Israel or the United States are doing. Nobody knows that. Except, of course, you know that I do. But this ties in directly with the state of science right now, which is a government-controlled operation. We have been brainwashed to think that anything you can look up in Wikipedia or get some textbooks or take some classes, that you can learn anything you want. No, you can't. That will never be possible again. Except I'm the odd man out. I'm a very, very strangely positioned human being in terms both of politics and in terms of cutting-edge science, because I was not brainwashed. Also, I have a religious aspect on things. In other words, I was sheltered from the world. I studied the Bible all my life. And however you feel about that makes no difference. In context, all I'm saying is I have a unique view on the atom. A unique view which is extremely simple. Roger saw it. He was a Jesuit priest back at a time when the Jesuits were actually being disbanded to a certain extent. But he was immune from any kind of trouble because he was the greatest physicist of his day. That's Roger Boshkovich, the man who corroborated my work. So what I was attempting to explain in the video in which I made the valence error can be better explained here. And now I need to just prepare you. There's a reason why I'm making very short videos. It's because this is so incredibly confusing. You will be confused. There is no way I can prevent that. But I can guarantee you that you'll get through the confusion as long as you're willing to. You kind of have to split your mind a little bit and just let a lot of shit pile up until I can take the whole thing and go dit, 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 and then everything will make perfect sense. And by the way, that process has a name. It's called science. I've been kind of megalomaniac lately in my statement in order to be emphatic that I may be among one of the last true scientists. Be that as it may, there are two curves here that you must understand. First of all, why it has baffled the living shit out of anybody who contacts this subject. But then the other aspect is, this is so simple that a child can understand it, which means that that part is what you want. This has nothing to do with the neutron. It also has nothing to do with the photon. It also has nothing to do with the standard model of particle physics. Nothing whatsoever, but there's a footnote. We'll come back to the footnote. Because the quark system represents a harmonic, and not even Gelman saw that. I saw it. The red line represents the relationship between two protons. Okay? Now, why would I emphasize that? It's because there's another atomic relationship, and I'm sure you can guess what it is. It's the relationship between one proton and one electron. Not two protons, 3 or 92 protons, which is the nucleus of a uranium atom. And that's the largest number of protons that occur in natural form. That is, we can actually dig up uranium. Back in the 1960s, it was worth about $25 a pound. And there were a lot of uranium prospectors and uranium miners. Because that uranium that you dig up from the ground cannot be used to make a bomb. Only uranium-230, I'm a little dyslexic, but there's two forms that occur naturally, but they're mixed, and they're called isotopes. Uranium-235, I am 90% sure, is the common one. But what is needed is uranium-238, which is heavier. In fact, that's the key to remembering that. And the way to get uranium-238 separated from uranium-235 has been called, certainly by John McPhee, who is simply quoting the physicists of his day, back in the 70s essentially, it's the hardest engineering task man has ever assigned to himself. It's by far the most difficult thing that a government can do, and only a government can afford to make a uranium separator. So far, certainly Russia has some. The United States has a few, but only one operational. China, of course, we're not sure how many they have, but they've had one for decades. And who knows who might get one. Because as long as you have enough money, you can get a separator, and then as long as you know how to do it, which is, again, the most difficult thing, the most difficult engineering task that mankind has ever undertaken, is to separate weapons-grade uranium from common uranium. So all of that is to say, we're not interested in that. But that's why the Hadron Colliders are colliding two protons together, is to see if an even deadlier weapon can be developed out of that. And it has to be done, it is thought, by government minds, which, again, are probably not human. But that might scare you, or it might make you laugh. Either way, it's an inappropriate topic to bring into a science presentation. Not because it's not true, it is true, but because you simply could not possibly understand what I would say about it. And so it's meaningless for me to try to convey information to you which you're so rigidly and doggedly against that you simply can't understand it. So I'm not going to say that. But now you know what I do think about that. So now these two curves are very simple, and as long as you look at them separately, they're very simple. So what's the top one? It's the relationship between two protons. And that's all it is. It's the relationship between two protons. But of course you have to say a little bit more in order to understand, why does the curve look like that? Why does it slope up from right to left and then go to infinity vertically? It also goes to infinity horizontally, but that's simply distance, linear spatial separation. And the relationship between the red line as it looks like a jet coming in for a landing, right? Of course it does. It looks exactly like a jet, a turbojet airliner coming in for a landing. And that is called Zeno's paradox, which I've solved. That relationship between the red curving line, which is sloping down from left to right to infinity, never contacts the horizontal line. And that relationship is called asymptotic. Now, going in the other direction, going from right to left, sloping up, you can see it's a very gentle curve, as if a turbojet airliner were taking off from a runway. But what happens at the far left side of the graph is one of the most baffling, unsolved problems that's ever faced the mind of man, which so far only two men on record have ever understood completely, and that's Boshkovich and Scott Miller. You've never heard of Scott Miller. Scott Allen Miller, he's alive today. You're looking at him. So those are the only two men that can describe that ultraviolet catastrophe. And for those of you who are in on the know, you know that that is a metaphor. So what does that show? It shows the relationship between two protons. And now I have to explain that to you. First of all, what is the relationship between two protons? It depends on the distance between them. And that's the significance of that black horizontal line. It shows the separation, strictly speaking, and you must say it the way I'm going to tell you, linear spatial separation. That is the definition of Euclidean distance. Distance has a technical definition which you will master right now. You have to say 3 words. Distance is not good enough. It could be if you could always explicitly define what you mean by that. Every single physicist falls into this trap. That they forget that that horizontal line only has one meaning. It's simply linear, spatial separation between what and what? Between what and what? An electron and a proton? No. We're going to get to that. Between an electron and an electron? No. But we'll get to that later. It's the separation between one proton and another proton. Now put them near each other. You have to know the scale, which is why I'm going to show you one more document before I explain this fully. Bear with me. This will be under a half an hour. We're at 23 minutes now. I simply want to go through these 8 terms very quickly so that you'll be braced for the very, very simple relationship, which then will become so complicated and so complex that you'll be in danger of just forgetting the whole thing, which is normal. Normally you should forget the whole thing. It's too complicated. It's too complex. But it's not going to be that way the way I explain it. But in order for you to see this, you have to know what the problem is. So the top word that we want to just quickly talk about is scale. Scale. At the scale we're talking about the atom. The scale is quadrillionths of a meter. Quadrillionths. Okay? That is called the femto range. Femtoscale is the right term. It's measured in femtometers. And the femtometer is the smallest scale unit used in physics. There is nothing smaller than that. Nothing smaller than that. For reasons which will become clear. You might think, well, why can't you have quintillionths? Because there's no such thing. And I'll be showing you that. That is actually known. And we're talking about the Planck scale. The smallest linear spatial separation in the universe is called the Planck length. And what makes that so spooky is that it's not actually a physical length. Because if it were a physical distance, which is what a length is, it's a distance, linear spatial separation, there's nothing in between. There's nothing in between 0 and 1 Planck length. The distance from 0 to 1 measured at Planck scale is not in space. And that's what's driving everyone mad. Now, I don't want that to happen to you. It will again when it comes up in the right context, but I'll guide you through it so that you'll be ahead of all the physicists. The scale that we're talking about is not the Planck length. It's the subatomic separation length between a proton and another proton. That is so simple, but it's absolutely critical that you remember that once we start talking about what we need to talk about in the Boshkovich force curve, which is not explicitly about a proton-proton relationship. Although Boshkovich himself didn't know which one it was, because there was no such thing as an electron, and no such thing as a proton, and in fact, no such thing as a particle. None of those had been discovered, and would not be discovered for over a century after he died. Now, I read his book, and I've read a lot of material out of Europe that's been translated into English, out of Croatian and out of Italian, where top-level work is going on that parallels mine, the only difference being I already have the answers, which sounds pretentious. That's why you're tuned in, isn't it? Is to get solutions. If you're not studying science to get solutions, you're not doing it for the right reason. We're all trying to get solutions who are working at the cutting edge, at the top, which gets philosophical. So I'm the real thing, and I will give you the solution. That's exactly what I'm doing. So the scale that we're talking about is not the second word down. That's molecular. Now, in Boshkovich's day, there was direct evidence there was such a thing as molecules. But that nothing smaller could be figured out until the late 19th century at the earliest. This is a progressive discovery of atomic structure, which is the third word down. Well, atomic structure is so ambiguous that you could spend the rest of your life studying atomic structure. Because you know what you're doing when you study that? Studying that? You're studying chemistry. Chemistry. You're studying chemistry. And that's not what we want. We're after higher game. We're after the answer for the whole universe. So we go to the fourth word down. Subatomic. Now it starts to get spooky. You know that when you've heard these terms in the past, you're being led into an area where you're just going to get lost. Because you're listening to government mathematicians. They get paid for talking around in circles, just as a politician lies in order to fool the public so he can get what he wants. That's called politics. It's about lying. But you have to tell a little bit of truth in order to gain the power that you need. But what you're actually doing is lying. And that's politics. Exactly the same thing happens in physics. It's a little more difficult, but I won't go into that because it would just confuse all of us. So we're not going to worry about the fact that it's a dangerous word that will drive you out of your mind and make you cry, and your fanny is going to itch, and you'll have to scratch it. He who go to bed with itchy butt, wake up with smerry finger. That was a joke I heard in the 4th grade. I thought you might like that. All right, so the next word down is nuclear. What does that mean? It means the protons at the center of the atomic system. So nuclear is subatomic, right? Is there anything else that's subatomic? Oh, yes. Can you guess? I'll bet you already know. The electron shells. The electrons. The electrons in the atom are part of the atomic system, but when you're talking about electrons, you're talking about subatomic particles. Subatomic. Subatomic. Because for a long time it was thought that the atom is actually the atom of the ancient world. That is the smallest indivisible unit. We now know that that's not true. But that was the original definition of atom. And so when you say subatomic, that's actually a contradiction. But it isn't anymore. That's just a little historical footnote. Now that should not be confusing. It's just that science has progressed, so that the definition of the atom has changed. Well, what's the new atom? Well, if the atom is not the smallest indivisible particle, have we found it? Yes, we have. Although none of your physicists say we've found it. It's the proton, of course. Why? Because it makes a position in space. The electron does not. The electron makes an orbit in space. So that's the beginning of this spooky part, which I will make sure that you do not lose your mind. You will not be confused, or I will fucking throttle you, because my reputation is at stake. So you be sure that you understand what I say, or ask a question. So there's only one atom in the old sense. There's only one smallest indivisible particle. It's the proton. There's no such thing as a neutron. We'll come back to that because you know there is. That's the beginning of superposition. And don't worry about that for now. That's one of the things that confuses even your PhD physicists, but it doesn't confuse me, and it won't confuse you. You can be confused and still make a bomb to murder people or kill them. You can do that, even though you're stupid, you're retarded, you actually don't know what you're doing, but you know just enough to make a goddamned bomb. Those are not scientists. They're killers. Okay? Whether you like that or not, that is actually what the universe says. And I only say what the universe says, not what a military bastard says, and not what a brainwashed juvenile delinquent says. You never talk back to me, because I can prove everything I say. They can't prove a fucking thing that they say. The standard model particle physicists, the cosmologists, they're insane, they're retarded, and they're evil. Every last one of them. Okay? It's too late to be dicking around and just playing patty cake. This is the way it is. So nuclear refers to the protons. Now, nuclear force is the beginning of the complications. Let me make sure that it is not complicated. I will define what the nuclear force is. Not Wikipedia. Not read my lips. Wikipedia has no idea what the nuclear force is, okay? It gets all of its information from those fucking bastards who all they know is they have to make a bomb in order to have a mansion, a Jaguar, and whores. Okay? That's how the world works, whether you like it or not. That's how it is. I don't do that. I don't take money. So the next one down is what I was talking about in the video and what I'll be talking about with you, that is to you, so that you'll know what it is, despite what Wikipedia says, and despite what anyone except me and Roger say it is. The strong force. And before we start talking about that, we're going to just go right to the bottom. The Coulomb force. Oh my God, what is that? Now, if you already know, You know it's simple. Here's a plus, here's a minus. That's what it is. It's plus and minus. What do those mean? Well, if you look up Coulomb force in Wikipedia, you will get the biggest dump truck full of bullshit outside of the cosmological constant. It should not be called Coulomb force. Do you know what it is? It's charge. It's called charge. And what is that? I'll be showing you what that is. Only I and Roger know what that is. Now, James Clerk Maxwell proved the relationship between a positive charge, that's a plus in every textbook, and the negative charge, which is a minus in every textbook, every classroom, from the CERN Super Collider down to high school, everywhere. It's the plus. What does that mean? The proton. The proton in the atomic system. So what's the minus? The electron. The electron is minus. So which one is at the center? The plus is. Now, whenever anyone does this, that is, makes a diagram, which we're going to show back again now. So here is where we're at. And now, because you know that we're simply talking about a plus, which is a proton, and a minus, which is an electron, this diagram here is a side view of an atom. It is an atom. Okay? Very simple. But how many protons are at the center? One. Just one. That's called a hydrogen atom, meaning there has to be one electron. That's the red line. Where is the proton? I'm going to use the pointer so that you will not be confused in the slightest degree. Believe me, if I don't do this, you will be confused so quickly, it'll make your fanny hurt. Everybody gets confused by this, but I'll show you how incredibly simple it is. Let's make sure of this now. There's our pointer. I know you can see it because I did some experiments. Here's the space line. Only this horizontal line is space. Everything else is non-spatial. We'll come back to that so that won't hurt your fanny or your brain or your mind. You're not going to be confused, or so help me, I'll jump through the screen and strangle you. So the proton is right there. Now, that's of course a projection this is a 2D graph. So the value of this point is 0, 0. Got that? That's going to come back to haunt you. It's not 0. It's 0, 0. This point is 0, 0. And that's the only point on this graph that is 0, 0. Why do you have to say 0, 0? Because there's a second line. This is called the y-axis of the graph. All of this is from grade school. You're going to relearn it, and you're going to relearn it the right way with me. This is the horizontal, called the x-axis. What does the x-axis represent? Don't get this wrong, or you flunk. It's linear spatial separation. I now give you permission to call that distance. That's what distance is. So the spatial aspect is only on this horizontal line. It's not above the line, and it's not below the line. Why not? The protons cannot go there. The relationship between these two protons is that they are both on this line. You know why? Euclid. Euclid, the shortest distance between 2 points, is a straight line. Okay, good. The rest of the graph is not space. It is not space. Okay? I'm not just making this up. So stretch your mind if that hurts you. Be sure that you understand what I just said. All right. So one of the protons is at 0, 0. Where is the other proton? Anywhere you like. Anywhere you like on the horizontal line. Because that other proton is trying to get toward, well, you shouldn't say that. And this is where it starts to get hairy. Could easily confuse you. Don't let this confuse you. I'm sorry I started off on the wrong foot. I made a mistake 2 years ago because this can just, you can confuse yourself. All right. You'll see that this is hatched. Maybe you can't see that, but don't worry that you can't see it. I'll tell you. This is a half a femtometer. This is a femtometer. This is 3 femtometers. That's 3 quadrillionths of a meter. That's an actual physical measurement that has been made. So this is a diagram. Looking sideways, so to speak, with a proton that is the inertial frame of reference. That means we don't allow it to move. It's stationary at 0, 0. And what these curved lines show is the relationship in force units between the two. What does that mean? It means if you have a proton at the 3 femtometer mark, right here, 3 femtometer, there's a proton there. Now this is the center of the proton. The proton actually has a radius, and that's actually a secret that I unlocked. It's very difficult to talk about the radius of a proton. But this point on the line is made of points. So it can't represent the whole proton. It can only represent the center of the proton. So the center of the proton, we're just going to say, is at the 3 femtometer mark. What does that mean? It means it's 3 femtometers from the proton whose center is at 0, 0. Okay? That's where the other proton is. So the distance is 3 femtometers. Now, let's say that the proton is there and it also is stationary. This is the simplest of the relationships. There are no electrons anywhere. There are just 2 protons so that we can graph what they experience in terms of the 2 forces. One would be attraction, and the other one would be repulsion. Okay, we're coming up to the mistake that I made 2 years ago. But I'm very glad that I made that mistake. I don't need fame and I don't need money. What I need is to say this right so you can prove it to yourself, because once you do, you'll be smarter than all the physicists who have ever lived. And you'll know more mathematics, and you'll be an expert at mathematics beyond the greatest teacher of mathematics of all time. I swear to that. So if you can get through this, which I will I will drag you by your hair until you get this. Because it's simple. That's why these bastards can't see it. All right. So now we have 2 protons separated by 3 femtometers, and neither one of them has any Newtonian, that's Newton, Sir Isaac Newton, no Newtonian velocity. None. They're just sitting there because we say so. Because we're freeze-framing this instant of time. And that's the status. What is the force relationship between those 2 protons? All right. That will be in the next video, where I'll show you the most confusing, the most confounding, the most baffling, paradoxical answer imaginable. And I'm just going to tell you the superficial answer so that you can go to sleep crying or losing your mind or hating me or hating science or hating God. Whatever you need to do, I will explain this in the next video because I'm exhausted. Okay? Here is what you can think about if you're still capable of thinking. There's no guarantee in my mind that you have a brain in your head at all. But this will test your mind, so you'll know how smart you are. And even if you're retarded, stupider than a rock, I will make you more intelligent than the most intelligent man that has ever lived. Whoever that might be. I can't imagine. So, what you do is, to answer the question, what is the force relationship between those two protons, neither of which has velocity, Newtonian velocity. They're just sitting there. And the question is, once you start action, that is, you just let them do what they're going to do, will this proton move away from the other? Excuse me. I told you that I'm quite excited. I don't have any beer, which is quite serious. It's well after 2 a.m. here. So this proton, which is sitting at the 3 femtometer mark, start action. Which way is it going to go? Is it going to go away from the 0, positioned proton? Or is it going to go toward the proton? In other words, is it going to try to collide with the other proton? Or is it going to run away in the opposite direction? Which one is it going? Or is it just going to sit there? Or is it going to do none of the above? So you have 4 possible answers. It'll go away, it'll go toward, it'll just sit there, or it'll go sideways, or into some other universe, parallel or otherwise, or just do something totally, completely unexpected. Which of those 4 answers is correct? 2 of them are correct. If you read up to read, you may not be able to read that, but that says electrostatic force. Can you see that? Electrostatic force. You know what that means? Charge. So I think you understand what's going to happen if you read that force line. Because protons repel. They both have the same positive charge, and therefore they run away from each other. And that's what that red line shows. That as this proton is that far away from the 0 proton, just read up, and that position on the curve, vertical from the 3 femtometer mark on the space line, that shows you repulsive force. Repulsive force. There's a second answer. If you read down, that's attractive force. And if that doesn't blow your mind, you weren't listening. I'll show you the secret. This is a magic trick. Only it's a magic trick that the universe pulls, and she's pulled it on all of the physicists, PhDs, Nobel Prizes. Doesn't mean shit to the universe. The universe favors me and Roger, and she showed Roger the answer, and nobody understood him to this day. Albert didn't understand. Tesla might have understood, but he didn't say one way or the other. But Nikola Tesla practically worshipped Boshkovich. He just didn't like to say so. You are going to learn more than Tesla ever learned. Perhaps. We're not actually sure what Tesla knew. But whatever Tesla knew, I know it also. And I'll be showing that to you. If I worked for the government, you'd already be dead. So maybe if you're a praying person or you like my happy face that I haven't killed you, thank God that I didn't work for the government. I might have, but I didn't. I was called to the way of heaven, and I'm sorry if that hurts your fanny. Okay? Thank you for tuning in. That's 50 minutes. Keep looking up. There's a half moon. I'm going to go out and look at it right now, and then I'm probably not going to make it back into the house. I'll trip over my own feet, collapse dead asleep, and wake up with the dew of dawn. Just like Nebuchadnezzar. The penalty of megalomania is you'll be reduced to a 4-footed beast, and you'll be humbled in that fashion. Until then, stay tuned, because later today, which is a Saturday, I will be giving you the secret of the universe, the secret of the atom, the secret of the force balance system that explains all transactions at all scales, including the supermassive black hole, dark energy, dark matter. All of these ridiculous terms are actually going to make sense. You're going to be the first person to understand quantum gravity and the collapse of the wave function. As for entanglement, you'll be able to explain it to your children if you ever have them, or if you do now. You'll be able to explain it to anybody. Just exactly what entanglement, collapse of the wave function, supergravity, black hole, even the Big Bang, which of course is absurd, but I'll show you the right answer. And how galaxies are formed, which Neil deGrasse Tyson has no fucking idea how galaxies are formed. How come he's so stupid? He works for the government. And the government is controlled by a supernatural power. The same one that's killing all of the Palestinians. So it all ties together. I hope your fanny doesn't itch. I hope your brains aren't pouring out your ears and your snout. I hope you tune in. Because I'm on your side. I'm a human. I think you can tell. Stay tuned. We'll be right back, I promise. I won't abandon you. Thank you.